Hello and welcome. When you look at the equation on the board, it's very easy to see that x equal to 4 is a solution because 4 minus 2 squared is equal to 4 and the square root of 4 plus 2 is equal to 4. But that is not the only solution. There are other values of x that satisfy this equation. So in this tutorial, our task is to find all the real values of x that satisfy this equation. And to do this, we are going to start with a substitution. So let the square root of x be equal to d. Of course, you know that with this substitution comes the condition that d must be greater than or equal to 0 because a square root must be positive. Now, when we square both sides of this equation, you have that x is equal to d squared. Now, the next thing we are going to do is that we will rewrite the original equation in terms of d. So here we have x, which of course is d squared, minus 2 squared, and this is equal to d plus 2. Now let us expand this. We have d squared squared, and of course that is d to the power 4. We have 2 times d squared times minus 2. That is going to give us minus 4d squared. And we have minus 2 squared, which is plus 4. Now let us move these two terms over to the left-hand side. So we have minus d and we have minus 2, and this is equal to 0. Now 4 minus 2 is equal to 2. So this equation is going to be d to the power 4 minus 4d squared minus d plus 2 is equal to 0. But now look at these two terms. You're going to see the difference of two squares because of course you know that we can write this as 2d squared. So here we have d squared squared minus 2d squared minus, let me introduce a bracket. When I do that, I have d and I have minus 2, and of course this is equal to 0. Now let us remember that a squared minus b squared is equal to a minus b multiplied by a plus b. In this case, d squared is a and 2d is b. So we can factorize this as d squared minus 2d multiplied by d squared plus 2d. And of course, we have minus d minus 2, and this is equal to 0. Now, when you look at these two terms, you're going to see a common factor, which is d. So here we have d into d squared divided by d is d, and minus 2d divided by d is minus 2. And of course, we still have d squared plus 2d minus d minus 2, and this is equal to 0. Now look at these two. You can see that here we have d minus 2, and here we also have d minus 2, so we can factorize that. So we have d minus 2 into, now when you divide this by d minus 2, you're left with d into d squared plus 2d. And of course, when you divide this by d minus 2, you're left with minus 1. And of course, this is still equal to 0. And of course, from here, we have that either d minus 2 is equal to 0 or this expression is equal to 0. So we have that either d minus 2 is equal to 0, or let us open this bracket, d times d squared is d cubed. D times 2d is 2d squared. and then we have minus 1, and this is equal to 0. Now, of course, you know that if we add 2 to both sides of this equation, we have that d is equal to 2. So already we have found one value of d. So we have that d is equal to 2. Now, in this case, we have a cubic equation. To solve this equation, let us use the trial and error method. Let us test for d equal to minus 1. Now, when we substitute minus 1 for d in this cubic equation, we have minus 1 cubed plus 2 times minus 1 squared minus 1. This is minus 1 plus minus 1 squared is 1. 2 minus 1. Now, minus 1 is minus 2. Minus 2 plus 2 is equal to 0. So you can see that d equal to minus 1 satisfies this equation. So d equal to minus 1 is a root of this cubic equation. And that simply means that d plus 1 is a factor of this cubic expression. So now what we are going to do is that we will divide this cubic expression on the left-hand side by d plus 1 to find the other quadratic factor, which we can then solve for the other values of d that satisfy this cubic equation. And to divide, we are going to use our synthetic division method. So we have the coefficient of d cubed is 1. The coefficient of d squared is 2. You can see that there is no term in d, so the coefficient of d is 0. Then the constant term is minus 1. And we are dividing by minus 1. Now you bring this down, so we have 1. Minus 1 times 1 is minus 1. 2 minus 1 is 1. Minus 1 times 1 is minus 1. 0 minus 1 is minus 1. Minus 1 times minus 1 is 1. Minus 1 plus 1 is equal to 0. Of course, now you know that this is the coefficient of d squared. This is the coefficient of d, and this is the constant term. So we have that the quadratic factor is d squared plus d minus 1. And of course, the product of these two is equal to 0. So now you can see that basically we have factorized this cubic expression on the left-hand side into these two factors. And once more, from here we have that either d plus 1 is equal to 0 or d squared plus d minus 1 is equal to 0. So we have that d plus 1 is equal to 0. When you subtract 1 from both sides of this equation, you have that d is equal to minus 1. So we have found another value of d. So we have that d is equal to minus 1. And finally, we have the last equation. Now, this quadratic equation cannot be solved by factorization method. So we are going to use the completing the square method. Now, since the coefficient of d squared is 1, the next thing we do will be to move this constant term over to the right-hand side. So when we do that, we have d squared plus d is equal to 1. And of course, the next thing we are going to do is to add the square of half the coefficient of d to both the left-hand side and the right-hand side to complete the square on the left-hand side. Now, what is the coefficient of d? It is 1. Half of it is 1 over 2, and the square of that is 1 over 2 squared. So we are going to add 1 over 2 squared to both the left-hand side and the right-hand side of this equation. So when we do that, we have d squared plus d plus half squared is equal to 1 plus half squared. Now, this is a perfect square. So this is equal to d plus half squared. Note that if you expand this, you're going to get exactly this. So nothing has changed. And of course, this is equal to 1 plus Half squared is 1 over 4. 4 times 1 is 4 plus 1, 5. So this is 5 over 4. And of course, the next thing we are going to do is to take square root of both sides of this equation. This is going to take care of that. And we have that d plus half is equal to plus or minus the square root of 5 over 4. And of course, this is equal to plus or minus the square root of 5 over the square root of 4, which is 2. From here, we have that d is equal to minus half plus or minus the square root of 5 over 2. So we have two more values of d. We have that d is equal to minus 1 plus root 5 over 2, and d is equal to minus 1 minus root 5 over 2. Now that we have calculated all the values of d, let us do our elimination process. Now you know that d must be greater than or equal to 0. So that eliminates this, and that also eliminates this. So we have that the only acceptable values of d are d equal to 2 and d equal to minus 1 plus root 5 over 2. And of course, now we have to find the value of x, because that is what we are looking for. And we know that x is equal to d squared. So when d is equal to 2, x is equal to 2 squared. X is equal to 4. And in this case, we have that x is equal to minus 1 plus root 5 over 2 squared. When you open this bracket, we have minus 1 squared is 1. 2 times minus 1 times root 5 is minus 2 root 5. And root 5 squared, of course, is 5, divided by 2 squared, which is 4. Now this is equal to 1 plus 5 is 6. So this is 6 minus 2 root 5 over 4. But of course, we can factorize this. We have 2 into 6 divided by 2 is 3. Minus 2 root 5 divided by 2 is minus root 5. And this is over 4. 2 into itself is 1 and into 4 is 2. So we have that x is equal to 3 minus root 5 over 2. And in decimal, x is equal to 0.382. So now we have the two values of x that satisfy this equation. X equal to 4, which is the very obvious solution. And then x equal to this, or 0.382. And with that, we come to the end of this tutorial. I hope you learned something new. If you enjoy such content, please subscribe to the channel. Leave us a like to support the channel. Thanks for watching, and you can see more videos here.